Determine all values of c that satisfy the conclusion of Rolle's theorem for the function f of x equals 2x cubed minus 5x squared minus 4x on the interval -1 included to 3 included. The first thing to do is to determine whether the three conditions are met for Rolle's theorem to be applied. The first condition, the function f of x, which is 2x cubed minus 5x squared minus 4x, has to be continuous on the closed interval given. Well, 2x cubed minus 5x squared minus 4x is a polynomial. And a polynomial is continuous on any interval, so this will be continuous on the closed interval given from -1 to 3. Closed means that it includes the endpoints, indicated by the square brackets on the endpoints. Condition 1 is met. The second condition, the derivative, f prime of x. First term power rule, bring the power down, multiply it with the 2, subtract 1 from it. Second term power rule, bring the power down, multiply it with the -5, subtract 1 from it. Third term constant times x, derivative is the constant. The derivative needs to be continuous, it's called differentiable, on the open interval. 6x squared minus 10x minus 4 is also a polynomial. And it's therefore continuous on any interval, so this will be continuous. It's called differentiable for the continuity of the derivative on the open interval. It's always the open interval. Open means that it does not include the endpoints, indicated by the round brackets on the endpoints, because a function is never differentiable on its endpoints. Condition 2 is met. The third condition is that the function evaluated at the left endpoint A has to equal the function evaluated at the right endpoint B. In this problem, we have the interval of -1 to 3. The left endpoint A will be -1, the right endpoint B will be a 3. We need to evaluate the function at the endpoints and see if they're the same. F of -1 and f of 3. Each of these will be evaluated by plugging into the function. F of -1 will be 2 times -1 cubed minus 5 times -1 squared minus 4 times -1. 2 times -1 cubed is a -1. Minus 5 times -1 squared is a +1. And then minus 4 times a -1 is a +4. 2 times -1 is a -2. -5 times 1 is a -5. Plus 4. -2 minus 5 is a -7 plus 4 comes out to a -3. F of 3 will be 2 times 3 cubed minus 5 times 3 squared minus 4 times 3. 2 times 3 cubed is a 27 minus 5 times 3 squared, which is a 9, minus 4 times 3, which is a -12. 2 times 27 is a 54, minus 5 times a 9 is a -45, and then minus 12. 54 minus 45 is a 9, and then minus 12 will be a -3. So we do have that f of the left endpoint does equal f of the right endpoint. So condition 3 is met. All three conditions are met here. Rolle's theorem does apply so that the slope of the tangent line at some value c from the mean value theorem will equal the slope of the secant line connecting the left endpoint and the right endpoint. Rolle's theorem is the special case where condition 3 is also met, f of a equals f of b, and if these two things are equal here, they will subtract to 0. So Rolle's theorem is the special case of the mean value theorem where the slope of the tangent line at some value c will equal 0. For at least one c, maybe more, in the open interval of -1 to 3. We're going to find all c values and keep those that are in that open interval. The left side, f prime of c, is evaluated by plugging c into f prime of x. That will give 6c squared minus 10c minus 4 equals 2, and the right side is 0. Since we have a trinomial quadratic, we're going to want to factor. Before we do that, there is a common factor of 2 that can factor out to reduce the numbers. That will leave a 3c squared minus a 5c minus a 2 equals to 0. And we can now trinomial factor. Since it's a 3c squared, it needs to factor to a 3c and a c. And we need two numbers that multiply to be a negative 2 and add to be a negative 5 after one of them is multiplied by a 3. 2 is 2 times 1. And therefore it's a 2 and a 1, and it looks like it may work if the 2 is put here and the 1 is put here. That will give a 6c and a 1c. We need the 6 to be negative, meaning the negative will be here and the positive here. And now that it's fully factored, we can solve for each of those factors equals to 0. There's a 3c plus 1 that can equal 0. And there's a c minus 2 that can equal 0. 3c plus 1, we're going to subtract 1 from both sides, so 3c equals to negative 1. Divide both sides by 3, c will equal to negative 1/3. c minus 2 equals 0. We can add 2 to both sides, so c equals to 2. We now want to determine whether they are in this interval. At least one of them will be, perhaps both of them. Between negative 1 and 3. Negative 1/3 is bigger than negative 1, but it is less than 3, so negative 1/3 is one of them. And 2 is also between negative 1 and 3, so this one is also kept, and so it turns out we have two values, negative 1/3 and 2, for c that satisfy the conclusion of Rolle's theorem.